This interactive polygon tool can be found at www.visnos.com. In this video, I'm going to be talking about using the terminal. The terminal is this black box here. When I click it, I get a bigger terminal and I can enter code into here. The code is written in the browser's own language, which is JavaScript. So I can enter code, click run. If the code is correct, you'll see success. If you've made a mistake, and this can be quite easily, even a small spelling mistake will render code useless, we get an error message. At the moment, we're only going to be writing a few lines of code, so finding where the error occurs shouldn't be too difficult. So let's proceed. Okay, so before actually going through the code, I'm going to actually just talk about what the radius means. So in this case, we have an equilateral triangle. I'm going to change that to a hexagon, and I'm going to give a circle color by clicking here and giving it a background color, which will make just a transparent gray. So the radius, in fact, will make the spokes appear as well. Okay, so the radius is actually the length of these spokes. So as you can see, that's going to be the radius of this circle. If I change the angle, you'll probably see that's a little bit clearer, and I can even show a ruler. So there you have it. You can see the radius there is 5. If I change it to 4, it's 4, 3, 2, and so on. But we can also do this programmatically by using the terminal. So I'm going to open the terminal, and instead of returning radius, I'm going to return 5. Now what do you think will happen? So I run, success, it's worked, and as you can see, we now have a radius of 5. And if I change this control now, the circle changes, but the radius doesn't, not of the polygon anyway. So as you can imagine, if I change this to 2, press run, the radius now is 2. Again, this has no effect apart from on the background circle. So the function takes two variables, an index and a radius. We've talked about radius. The index now, this is going to be a number which is an integer or a whole number, and it ranges from 0 up to the number of sides. So in this case, this could be 0, 1, 2, 3, 4, 5. So it's actually sides minus 1. So let's see what we can do with this. I'm going to multiply the radius by the index. And we have an odd effect here. Let's reduce this radius here and see if we can see what's happening. So what's happening is the radius, the spokes if you like here, are all getting larger as the index is increasing. So I'm going to increase the number of sides. And so you see you have this kind of shell-like effect. So why is this? What's actually happening is when the index is 0, we have 0 times, in this case, 0.3, which is 0. Then we'd have 1 times 0.3, which is 0.3 here. Next one, when the index is 2, 2 times 0.3, 0.6. 3 times 0.3, 0.9, and so on. Okay, next, I'm going to look at conditional statements. I've made a couple of changes here. So the radius at the moment is 1, and we're just returning radius. So I'm going to change this. So I've made the text bigger as well to see clearly. So actually we'll start with this one. If index equals 0, return 2, else return radius. So what this is doing, you'll notice there's 2 equal signs. That's how you test for equality. If you only have 1, then it assigns that value. So if index equals 0, return 2, else return radius. So what will happen? At the moment, this is the point with index 0. The rest, 1, 2, 3, and so on. So I'm going to run the code. Now, as you'll see, these all have a radius of 1, spoke length of 1. This has a spoke length of 2. What happens when I change the radius? Well, you'll see this point is fixed. Okay, that's that part of the conditional, because it always is 2. If I changed it to 1, it'll always be 1. I could change it to 0, and it's 0. Okay, so that's the first conditional. Okay, let's look at another conditional. Greater than. Okay, very important mathematical symbol for inequalities. And obviously this is using logic as well. So, if index is greater than 2, return 1, else return radius. So let's think what that's going to do. So this is 0. If it's 0, is 0 greater than 2? It's not, is it? So you return the radius. Let's run that and see. So you get the radius there, which is 3. If it's an index of 1, is 1 greater than 2? It's not. So we return radius again. What about 2? This index 2. Is 2 greater than 2? No, it's not. So we return radius. So finally we get to 3. Is 3 greater than 2? Yes, it is. We return 1. So we can see this is 1. 4, it's greater than 2, so we return 1. And 5 is greater than 2, so we return 1. So again, if I change this, you'll see some points are going to move, some points aren't. So you probably realize there's actually virtually endless possibilities here. I don't have time to do a video which is going to go on forever, so I'll just show you. You could change that symbol there to index is less than 2 to get a different result. But the last thing I'm going to look at, which is a very useful operator, is this. Looks like a percent, but actually in computing it means modulus. So what it actually does is index %2, or index modulus 2 I should say, returns a remainder when dividing. So if I divided 5 by 2, there's a remainder of 1, so that would be the result of this. So what we can do is then say equals 0. Whenever there's a remainder of 0, it means the number's been divided exactly. So in this case, index %2 equals 0 is actually a test for even numbers. So when I run this, we're getting, when it's an even number, return 1. When it's not an even number, return radius. See that? And we could make this consistent, so the whole shape changes. So I could do radius divided by 3, for example, and run. So as we change the sides, we get this kind of thing. So this small amount of code has now given us a type of shape that can be used for some investigations. So we could look into the symmetry of these shapes as the number of sides change. For example, this polygon with 18 sides currently has a vertical axis symmetry. But perhaps more interesting is if we look at the number of sides and how it relates to rotational symmetry. So if you change the sides, you'll come up with a rule fairly quickly. Only certain types of numbers have rotational symmetry, and then you can further investigate what the order is for those numbers. Okay, in this video we've covered an incredible amount. It'd be very difficult for anyone to actually take all of that in. So all I can suggest is you try the code, you make changes, you decide what's going to happen when you make the change and see if that's, what occurs. The last thing I'm just going to show you very briefly is we have here var val, and we're going to assign it a different number, very much like the last example. Now, what we're actually doing here is we have console.log index, val, and that means we can actually see the numbers that are going to be returned. So I'm actually assigning this val either radius divided by 5 if it's an even number, or I assign it radius if it's an odd number. Okay, so then this console index val will print out the results. So we use the browser's developer tools in order to actually see the results. To get them varies depending on your browser, but in Chrome we right click the window, click inspect element, then click console, and then you can see the results appear in that window. So 0, 0.86, 1, 4.3. So you'll see some of them at a radius value. If I change this, the results will change. So you can see sometimes you get 5, sometimes you get 1, because that's going to be 5 divided by 5, giving you 1. Right, that is enough. Thank you for watching. You'll find the activities at www.visnos.com.